Okay, let's start with today's practical, which is thermistor. Generally, thermistor means it's a thermal resistor. It's a combination of some compound or some ceramic or some materials which will respond to change in temperature. And how will it respond? It will respond by changing resistance. So the combination of both these factors makes this different from resistance, and hence name thermal resistor or thermistor. It is used in construction of resistance thermometer. So how is it manufactured? It is generally manufactured with some metallic oxide, which is the actual resistive material that responds to change in temperature. However, you should also remember that thermistors, they don't work extremely well at high temperature. So their limitation is they are bad at high temperature. However, they can be used within temperatures, say maximum up to 50 degrees centigrade. So you can use them up to 50 degrees centigrade. But why should we use them? The point is they are cheap. They are relatively cheap, and they can sustain several forces. Like you don't have to use it very carefully. That means they are durable. Even if they fall from the hand, they will not break. And they are very common for resistance thermometer, especially those digital resistance thermometer. They are also used in, what are the applications? They are generally used in this cooling element or heating elements of the circuit. In aircraft, they have something called like something to sense the temperature of the fuel cell. Why? Because the aircraft is carrying kerosene. That's called jet fuel. The problem with jet turbine fuel is that it is explosive and it will catch fire easily. So you need to keep in check what is the temperature of the fuel tank. So a thermistor is connected to the fuel tank and it's always on. So whenever this fuel tank may get heated up, they are sensing it. So unlike they shouldn't explode, because the fuel tank is just above the engine, it can get heated up. Generally, another is my field. It's also used. Laser devices, especially gas laser. In laser, thermistor is used for checking temperature and stabilizing the laser device. And they are also used in charge coupled devices. Generally, a 10 kilo ohms thermistor works best for laser devices. Now you should also know thermistor is not a linear device. It's a non-linear device. But only a very small range, it is a linear device. There are two types of devices. One is thermistors can be classified as PTC or positive temperature coefficient device and NTC or negative temperature coefficient device. In positive temperature coefficient device, resistance goes up as temperature goes up. But in negative temperature device, resistance go down as temperature goes down. And this NTC or negative temperature coefficient device thermistor is very popular. This device is also used as fuse, this automatic fuse. Now, how will they change the, like, how will you measure temperature using this device? Say for instance, you have a thermistor connected to a ohm meter. So from here you get the resistance. Now, how will you convert this resistance value to temperature? What will you do is you have a resistance temperature table. So since this is known, the resistance is known, you can look up this table and find temperature from this table. So basically you need a table to look up. So whatever resistance you get, you must look it up from the table and then convert it to temperature. Now let's compare thermistor to other device. There are a lot of thermal sensors. The first one is we have studied before is resistance thermal detector or RTDs. Thermistor, why is it good? It is durable, as I said. It is also sensitive. It can sense very small change in temperature. It is small. Basically, it looks like a capacitor, a ceramic capacitor like this. It is cheap, relatively very cheap, and it is good for measurement of point temperature. You keep it in contact with some device, it will measure your temperature. These are all pros. Now come cons. What is the bad thing? Why it is bad? First is it's non-linear. So you have to do some extra complicated calculations or circuit complications to convert. Another is temperature range is limited. It cannot measure everything. It will have a limited temperature range. For instance, I have already said it's 50 degrees centigrade. So after that, it will not be very good. What are the shapes and sizes? They are available in various shapes and sizes. It can be like this, it can be like a rod. It can be anything, like a cylinder, then it can be mounted on a surface, it can be like a wire diagram, anything. Generally, what thermistor does is it's always connected to a temperature like controller. That's the best application. It is always connected to a temperature controller. What we'll do is the temperature controller will draw current from so for instance this is a heating device or a cooling device. So let's go to in this slide, let's make an AC circuit. You have the AC here. The AC receives current from power, but instead of directly connecting the AC, you have a temperature controller which senses the temperature via thermistor. And what will happen is this temperature controller will send a bias current from here to the thermistor. The bias current will run from thermistor, sense the voltage there. Since it's a current, thermistor, there will be a change of resistance. So I into R will give a change of voltage. That voltage is measured by temperature controller. From that voltage reading, it will determine it should turn on the AC or not. Then ultimately, it's depending on the condition, it sends some voltage to the AC. That is called control voltage. This is a term from control system. This is your input AC. So it will keep adjusting the AC depending on the bias current, depending on the voltage that results from the bias current and the temperature, or from the or monitored or received by or detected by the thermistor. Now generally you cannot place the thermistor anywhere. You have to place the thermistor close to the source. Place this thermistor close to the spot whose temperature is to be measured. So generally it is attached there to the device whose temperature is to be measured. The more accurately you want the reading to be, the more close you have to keep it. Now thermistor, the next topic is categorization. How many categories of thermistor there are? Generally they are categorized in terms of the range of temperature they can measure. We know that 50 degrees centigrade is the ambient measurement temperature for them. Not extremely high, not extremely low. The best thermistor can measure from minus 155 to 114 degrees centigrade. That is the limit. So, but don't let it measure this whole range. Better measure anything close to its average range. That is the 50 degrees centigrade. That is basically the ideal range. Okay. Another point to know is thermistors are more sensitive at low temperature. When temperature is lower, thermistors are more sensitive. And there is also a voltage limit. Okay. There is also a voltage limit to how much voltage you can apply to the thermistor. Why? Higher voltage will cause self-heating of thermistor because thermistor itself is a resistance. And when the thermistor heats itself, it will heat up the environment, causing heat to be generated from the thermistor, which will result in environment temperature changing. And the thermistor will give you wrong reading. So don't supply high voltage or high current through the thermistor. It will cause the thermistor to heat and it will make it bad. Now there is a model. Generally thermal resistance, we don't consider, like for instance, if you are designing a controller, microcontroller circuit, which is connected to a thermistor, you won't be always considering the use of table. That will make it manual and not automatic. So you want an automatic system to convert resistance measured to voltage. So for that, we need something called a thermistor model, a mathematical model that will work well. And to this mathematical model, your input will be resistance and your output will be temperature. So that model, the best that have worked till now, is Steinhardt model. It is a very simple model that are generally programmed as a software into microcontrollers or your temperature detector devices that can take in the resistance and output the temperature. The accuracy of this model is very good and can operate, but its accuracy, this can work over a wide range of temperature. But Steinhardt equation works well when temperature ranges are low. Its accuracy increases. That's it for this lesson. So in conclusion, we can say that thermistor is a device whose resistance changes when temperature changes. So it's a thermal dependent resistor. And they are perfectly suited for scenario where small changes in temperature changes needs to be measured. They can measure temperature of liquid, solid, and gas, but that the thermistor will differ. Some require attachment to the solid, some require dipping, that like wire type thermistor or cylindrical thermistor, which will be dipped into the liquid. Now, best application for thermistor is for coolers, like ACs and all. What they do is they form the part of temperature controller circuit, which regulates the bias voltage to your AC. The close the thermistor is to your device, to the sensing environment, the more accurate your measurement will be. So that's it for this chapter. So we have the question, what is thermistor? It's a thermal resistor whose resistance changes depending on the temperature. State the limitation of thermistor. It cannot range, it cannot accurately measure very high temperature. Generally, its ambience is 50 degrees centigrade, which is good. Some application, one is temperature controller. This is a very good application in heaters, ACs, everywhere. So advantages of thermistor. Thermistor's advantage you can measure, like we know it's durable, sensible, small, cheap, and it can be like a best use scenario is single point temperature measurement. Disadvantage, they are non-linear and limited temperature. You can then it's name some types of thermistors. It can be like the thermistors which comes in various shape, like rod, chip type, like that. Why and how it's used in measurement in temperature controller. The thermistor generally senses the temperature, and the temperature changes are detected by through the bias voltage usage. Why is it used? Because thermistors are more sensitive to change in temperature, which the temperature controller will use, like the resultant changes the temperature controller will use to control the devices like AC and all. How to determine which resistance and bias current to use. That is already given. You will use a smaller bias current, and that shouldn't cause self-heating of the thermistor itself. Another is the bias current should be limited to, so that the temperature is like the thermistor itself don't get heat and disturb the reading. What is excitation voltage range for the thermistor control? You will get the answers there. Then like your excitation voltage should be like in it should be sufficiently limited, like it should be sufficient enough to have efficient bias current or enough bias current. Whereas it should be also like that it should be ideally at the center of the range. That is it shouldn't be extreme. You should consider the data sheet for it. What is the purpose of using Steinhardt equation for transistor? It's basically that the equation is a model that helps in conversion of measured resistance into temperature. That's it for this experiment. So I will stop the recording now. It's all done. Anybody has any question? কারো কোনো question আছে? Okay, I think nobody has question.